Hello everyone. So in this video, I'll go through what is TensorFlow, why TensorFlow, and what are its advantages and basic use of TensorFlow in data pre-processing and building a small neural network based on some preloaded data set in TensorFlow. Uh, so to begin with, what is TensorFlow? TensorFlow is a free open source library for machine learning and artificial intelligence. It can be used across range of tasks, but has a particular focus on training and inference of deep neural networks. This means basically it's a free open source library which we can use for machine learning and artificial intelligence, and it's mainly focused on deep neural networks. So why TensorFlow? Why to use TensorFlow? First one, prepare data. TensorFlow can be used to process and load data. So we have standard data sets preloaded in TensorFlow which we can use for training our models. And additionally, it is AI tools help you to uncover and eliminate bias in your data to protect fair and ethical outcomes from your models. So second one is build and fine-tune models with TensorFlow ecosystem. Uh, TensorFlow allows us to use pre-trained models which we can use which we can customize and use according to our data sets and use that in a real world problem. Deploy models on devices. This means we can use our built model on mobile phones, uh, microcontrollers, CPUs, GPUs, and many other platforms. Now we'll see how to install TensorFlow. So we'll go to this official website of TensorFlow. Official website looks like this, and TensorFlow. So these are the platforms which shows on which the TensorFlow is supported. And if you are Jupyter notebook user, then just it is very easy. Just make sure that your pip is upgraded. It's a latest pip version, or else you just use this command pip install upgrade pip, and then to install TensorFlow, like just put this command pip install TensorFlow. And if you are a Google Colab user, TensorFlow is already preloaded on it, so it's no worries. You can just directly import TensorFlow and use it. So coming back to this notebook, so we are using Jupyter notebook here. So we'll install pip install. We'll install TensorFlow using pip install TensorFlow command. So this goes like this. So, yeah. So as I've already installed TensorFlow on my notebook, so it says requirement already satisfied. If you are a new user and not installed TensorFlow, so you can use this command and install it. So now we are ready to use TensorFlow, and we'll use this to load and pre-process some image dataset which is already available on TensorFlow library. So before we begin, we'll import some libraries. So NumPy, OSPL, these are some image processing libraries, and we are importing TensorFlow STF and import TensorFlow datasets. So if you are not installed TensorFlow datasets in your computer, just put this command pip install TensorFlow datasets. We are using this TensorFlow datasets to take that a preloaded dataset and pre-process that dataset. So make sure that your TensorFlow version is about 2. So to make sure that just print this, use this command print tf.version. So you'll get the version of this. As you can see, the version is 2.91. So if it's about 2.0, then it's fine. So now we'll download this flower dataset from TensorFlow from this URL. So you don't first thing, you don't need to worry about this code. You will get this code on internet. You can use this. So I'll not just go through all the commands in the code. I'll just go through what we are actually doing from this code. So yeah, just we'll run this, and now it's downloaded. So after downloading 218 MB this complete dataset, we'll check how many images, how many data points we have. So using this command, we have 3670 data points. So we'll just check what are the images we have. So to check, we'll create a list roses which will take images from the directory roses, and we'll check. So this is the first image that is present in this data set of ours, and this is the second image. So we'll just run again and see. So yeah, so this is the second image. You can see roses of at index 0 and at index 1. So now we have downloaded our dataset. So it is our time to load dataset using Keras utility. Let's load this images of this using the helpful Keras tf.keras utility image dataset from director utility. So now we are creating a dataset. Before we create dataset, we'll define some parameter. Batch size is nothing but uh, the number of data points will pass in at one iteration through in forward propagation in a neural network. So image height we are keeping constant for all images, so we are keeping it at 180, and image width is also at 180. So now we'll create our train data set. So we are creating train data set, and we are keeping validation at 0.2. That means 80% of the data will go to train data set and 20% will be validation split. And we are giving image size which we defined as 180 into 180, and batch size as 32, which we have already defined. So if we just run this code, we'll get we have 3670 data points, and in that 2936 are for training files. And next we have validation dataset, same thing, and we have 20% of 3670, that is 734 for files for validation. Now we are ready with our training dataset and validation dataset. And now we'll see what are the classes present in our dataset. So we'll just print the class name. So we have five flower names as is. It will just print. Yeah. So now we will visualize these flowers with their names. So this code is just basically we are printing 9 flowers with their names, which is already present in our dataset. So first one is roses, tulips, sunflowers, roses, tulips. Yeah. So these are 9 images. Now you can train model using datasets by passing them into model.vector. So this is as we are ready with the dataset. You can just use model.fit and create a model for this dataset. So now we are checking the dimension of our dataset. So our dimension goes like this. We have 32, 180 into 3. So our dataset is a tensor of dimension 32, 180, 183. So 32 here refers to batch size, 180 is our height, and second this 180 is our width, and 3 refers to, so this is where RGB, right? So color red, green, blue. So last dimension refers to the color. So now we'll require we may that RGB values will range from 0 to 255 range. So which is not good for us to give that values ranging from 0 to 255 into our neural network. So we'll just standardize our data points between 0 to 1 using our uh, keras.layers rescaling function. So normalization layer equal to, using this command we are just dividing all the pixels by 255. So pixel value, so it will be the values will be in between 0 to 1 now. So yeah, so as we can see we are we are just checking for first image. So first image it shows the minimum value of the minimum pixel value is 0 and maximum pixel value is 0.969. So it means that our data is standard normalized. Yeah. So here I have another notebook. So in this notebook we'll just go through building our neural network and using TensorFlow. Yeah, so you don't need to worry about all these functions. These are, you can get it from internet. Yeah, so I'll just go through this quickly. we are using FMNICST dataset, and we have 10 classes in this. This is a fashion dataset in which we'll build a neural network that will classify the images into this 10 classes. So we have 6,000 train images and 1,000 test images. So this is one of the image from the dataset, and this basically we are doing same thing we did for flower dataset. We are printing the image and its corresponding name class. So again we are normalizing the pixel values between 0 to 1, and we are building a sequential module. Then yeah, so we created a model. So these are different layers. We are having two layers, dense and dense one, and so now at last we are fitting the model. So as you can see this, I'm not running this as it takes a lot of time to complete all epochs. So epochs is, you can say, epochs is the number of times that complete data set goes into the neural network back and forth. So at first epoch, as you can see, this accuracy validation accuracy is increasing. So this is training accuracy and this is validation accuracy. It goes on increasing with number of epochs. As you can see, at 10th epoch the validation accuracy was 0.8839, and at 11th epoch it was 0.89. So at we are stopping at 11th epoch. So we are launching the tensor board, and this is how a tensor board looks like. So in this tensor boards we have different options, scalars, graphs and all. So we'll analyze what is scalars. So these are some uh, logs that we have, like how many times we have done uh, run model. So this is the latest run I have done on my model, and we'll analyze this. So first graph shows epoch accuracy. So that means, so how the accuracy of validation set and training set increases with number of epochs. And this you can see, so here the green one refers to green line refers to training data set, and this gray one is validation data set. So as you can see, after some point this training accuracy goes on increasing with number of epochs, and but this validation accuracy after some time it becomes kind of constant. So that means we can refer that from this that mod after some number of epochs the model starts to overfitting. So from this tensor board we can analyze to get the optimum number of epochs we should run the model for. And this is same as like this is epoch loss, and this refers to just kind of opposite to that. So it shows the loss function. So loss function decreases with number of epochs, and for training it goes on increases, but for validation dataset it becomes kind of constant after some time. And we have graphs, we have distributions, and we have histograms. And histograms here we had two layers, dense one and dense zero. So with number of epochs you can see 1 2 3 4 5 6, like we ran it for 10 11 epochs. So it shows how weights of the neural networks are incremented and updated. So it shows the distribution of weights of neural networks. And yeah, this is for train. And yeah, so this is for first layer, and we have another layer. uh, so this is the weights of another layer. So this goes like this. So this is first at 0th epoch, and 1 2 3 4 5 6, it goes on like this, how weights are updated and weights distribution basically of neural networks. So our test accuracy, our model test accuracy comes out to be 0.881, that is 88.1 percentage, and we'll predict some one of the image. So yeah, so this is we are using some image at index 189. and we are checking the prediction and it says sneaker. And yeah, so we are printing that image and it is actually a sneaker. So our model is working fine. So yeah, that's all from this video. Thank you.